Humans have always considered themselves intelligent beings, capable of solving problems, building civilizations, and uncovering the secrets of the natural world. Yet when we turn our attention to the cosmos, the vast expanse of space and time that surrounds us, we're forced to confront the reality that our understanding is still in its infancy. For all our achievements in science and technology, we have barely begun to scratch the surface of the universe's mysteries. Our universe is estimated to be around 13.8 billion years old, a time span so immense that it defies ordinary human comprehension. Even more incredible is the fact that it continues to expand, its boundaries stretching farther every moment. But despite this knowledge, the most fundamental questions remain unanswered. What came before the universe? Why did the Big Bang occur? What triggered the birth of everything we see and know today? These questions lie at the very edge of science and philosophy. They form the core of what many physicists and cosmologists have spent their lives trying to answer. The difficulty lies in the fact that we cannot directly observe the birth of the universe. The event itself is too far back in time, too veiled by the early conditions of space, and too altered by the evolution of the cosmos. While we have made strides in developing models and gathering indirect evidence, our vision of those first moments remains obscured. Still, the scientific community has never been deterred by this challenge. One of the most significant advancements in recent years has come in the form of the James Webb Space Telescope, a technological marvel that may offer our closest view, yet into the origins of the universe. The James Webb Space Telescope, often abbreviated as JWST, represents a leap forward in astronomical observation. Unlike its predecessor, the Hubble Space Telescope, which primarily observed the universe in visible and ultraviolet wavelengths, JWST is designed to observe infrared light. This difference is crucial. As the universe expands, the light emitted by its earliest stars and galaxies becomes stretched, shifting into longer wavelengths that fall into the infrared spectrum. Because of this, JWST is able to detect light that left its source more than 13 billion years ago, effectively allowing scientists to observe the universe as it appeared in its infancy. In other words, this telescope functions as a kind of time machine, showing us what the cosmos looked like near the very beginning. Before delving further into what JWST is revealing, it's important to understand why the Big Bang theory holds such a central place in modern cosmology. According to this widely accepted model, the universe began as an unimaginably small, hot, and dense point, what scientists call a singularity. In an instant, this point expanded rapidly, setting off a chain of events that led to the formation of all matter, space, time, and energy. Over time, this rapid expansion slowed, and matter began to clump together under the force of gravity, forming stars, galaxies, and eventually the large-scale structure of the universe as we see it today. Despite the elegance of this model, we have never been able to directly observe the Big Bang itself. Much of our understanding is built on theoretical calculations and secondary observations. One of the most important clues to the universe's beginning is the cosmic microwave background, or CMB. This faint radiation is the oldest light in the universe, and it serves as a relic of the Big Bang. It was first predicted by scientists in 1948 and discovered by accident in 1965 by radio astronomers. The CMB is a kind of echo from the early universe, a glow left behind from a time when the universe cooled enough to allow light to travel freely. And yet, even with this discovery, many questions remain. What exactly triggered the Big Bang? How did matter and energy begin to behave in those first few moments? Why does the universe have the structure it does today? To begin answering these questions, scientists turned to new technologies. The James Webb Space Telescope was launched, not just to replace Hubble, but to push beyond the limits of what we've been able to observe. Positioned at a location known as the second Lagrange point, L2, it orbits the Sun at a distance of about 1.5 million kilometers from Earth. This remote position allows it to remain stable and avoid interference from Earth's heat and light, giving it a clearer view of the cosmos. In contrast, The Hubble telescope orbits just 570 kilometers above the Earth and is still affected by our planet's presence. The difference in positioning alone makes JWST far more effective at observing faint, distant objects. In addition to its advantageous location, JWST boasts some remarkable design features. Its primary mirror spans 6.5 meters in diameter and is made up of 18 hexagonal segments, coated in gold to maximize reflectivity. This large surface area allows the telescope to collect more than 6 times the amount of light that Hubble could gather. That increase in light gathering power means that JWST can detect extremely faint sources of light, such as the first stars and galaxies that formed in the early universe. It also features a 22-meter sunshield that protects its sensitive instruments from heat and light, keeping them cold enough to detect weak infrared signals from billions of light-years away. The telescope's potential was immediately demonstrated when, on July 12, 2022, it released its first full-color images. These images included breathtaking views of the Carina Nebula, Stephan's Quintet, and deep-field galaxy clusters. Each image offered an extraordinary glimpse into regions of space that had never before been seen in such detail, and this was only the beginning. Soon afterward, JWST made one of its most astonishing discoveries to date. It detected a galaxy that formed just 300 million years after the Big Bang. While that might sound like a long time, in cosmological terms, it is incredibly close to the very origin of the universe. Observing such an early galaxy provides a rare opportunity to study how the first structures in the universe began to take shape. Even more surprising was the discovery of 6 massive galaxies that appeared far earlier than anyone had expected. These galaxies were spotted between 500 and 700 million years after the Big Bang, yet they were far more massive and mature than current models of galaxy formation had predicted. Some may be as large as the Milky Way, a startling finding given that the early universe was thought to be chaotic and too turbulent for such structures to form quickly. These observations challenge long-held beliefs about how galaxies form and evolve. Until now, scientists believed that the process of galaxy formation was gradual and required billions of years. But JWST's discoveries suggest that galaxies may have formed much earlier and more efficiently than we once thought. If these findings hold up to further scrutiny, they may require us to rethink the history of the cosmos and revise our theories accordingly. WST's impact isn't limited to deep space or ancient galaxies. It is also transforming the study of planets beyond our solar system, exoplanets. In just its first few months of operation, the telescope examined the atmosphere of an exoplanet named WASP 96b. It detected the presence of water vapor, clouds, and various chemical compounds in the atmosphere. These types of observations are significant because they represent the first steps in a broader search for potentially habitable worlds. By analyzing the composition of distant planetary atmospheres, scientists can begin to identify which exoplanets might support conditions suitable for life. All of this points to one undeniable truth. The James Webb Space Telescope is fundamentally changing our understanding of the universe. With every new discovery, it is challenging our assumptions, expanding our knowledge, and opening up new questions we hadn't even thought to ask. It is showing us that the universe is more complex, more dynamic, and perhaps even more surprising than we ever imagined. What might the telescope reveal next? Could it detect the first stars that ever ignited? Might it provide insight into how black holes formed so early in cosmic history? Could it even offer clues about what existed before the Big Bang? If such, a thing is even possible to know. For now, we can only watch, wait, and continue to explore. As the telescope continues its mission, the answers to some of the universe's most profound mysteries may finally come into view, not just transforming what we know about space, but reshaping our place within it.